Hello again, summer science students. It's officially week 2. I hope you guys had a nice weekend and it was relaxing. We're starting lesson 1. Just a reminder, if you're first joining us, my name is Ms. Wistowski. Let's go ahead and get started. Okay, just some important information since it's only still week 2. I need you to check in on Schoology Conference every day so I can mark you present because you get 5 points for checking in with me on Schoology Conference. Remember, it's all or nothing. 5 points just for showing up on Schoology Conference, 0 for not checking in. If there's an issue where your power's out, your internet's out, your laptop stops working, please get a hold of me via email, Schoology messaging, or text. And if you want my phone number, I will let you know on Schoology Conference if you prefer that method. So every day there are 2 quizzes for you to take on GradPoint. We just finished our week 1, so 5 days, 5 times 2 quizzes. We've had 10 quizzes so far. Remember, there's a grade for every quiz, 5 points for above a 65, 2 points for below. So you want to aim for above a 65. And you can do this by trying to take notes on YouTube Summary. And please remember that if you're looking on YouTube Summary to take notes, the red word is always the vocabulary word, and the underlined word is the definition of that vocabulary word, and that will really help you with your quizzes. All right, again with the quizzes, just to let you know, everything in yellow should be done by now. So let me just give you a little overview. Here was the work on Monday. Here was the work on Tuesday, Wednesday, Thursday, and Friday, and we will have 2 more quizzes for today. All right, speaking of today, here's our work. We're going to need to read Levels of Body Organization through Homeostasis on GradPoint, and also take quiz Levels of Bodily Organization and quiz Homeostasis on GradPoint. So those are our 2 quizzes for today. Okay, please pay attention because we are in a new unit. We're done with Unit 1 already, and we are now in Unit 2. So make sure you're clicking the Unit 2 folder. You're going to get a screen that pops up that looks like this, and I need you to click on the Introduction folder or the number 1 folder underneath Unit 2. When you open that, it's going to look like this, and we're going to do all 4 things in this itty bitty folder. That is our lesson for today. Okay, so if you're ready, we are going to start the grad point summary where I summarize the most important pieces of information from our 2 chapters today. Let's start off with levels of bodily organization. The smallest part of any organism, and remember, organism is a fancy science word for any living thing, the cell. So the smallest part of any living thing is the cell. And groups of cells that hang out together are called tissues. Groups of tissues that hang out together are called organs. Groups of organs that work together are called an organ system. So we already learned this in our first week. This is the levels of bodily organization of living things. So we've got a picture of a horse, but all living things are organized the same way. Okay, so the smallest unit of any living thing will be the cell, and the largest unit of any living thing will be an organism. So again, cells will be the smallest unit of human organization. So you are a living thing, so your smallest part of you is a cell. And an organ, which again are groups of tissues that work together, an organ are the largest single unit of human organization, because organ system is more than one. So organ will be the largest single unit of human organization. So again, this what you're looking at, this little system, this is the levels of bodily organization from smallest, the cell, to largest organism. All right, so again, I want to look at this in more detail, and I want to give you some examples of different levels of bodily organization. So let's start off with the cell. There are many different cells in our body, and please remember that inside of cells there are organelles. A famous organelle would be the cell membrane, which protects the cell and forms a boundary or a border. An example of a tissue that you'd find in your body is called epithelial tissues, and you can find these in many different places in your body because they cover the body inside and outside. So they actually are found inside your stomach, inside your lungs, but they're most famous for making up your skin. So if you can say like, "Oh, I have a cut on my skin," you'd be like, "Oh no, I have a cut on my epithelial tissue," and everyone would be like, "Oh, you're so smart." Okay, an example of an organ system. So we skipped over organs. There are many examples of organs like heart, liver, brain, lungs. I want to talk about organ systems. Remember, organ systems are a group of organs that are working together. So an example of an organ system is a circulatory system, which is going to transport or move materials to and from cells. And this includes your blood, your heart, and your blood vessels. So in each organ system, you're going to have a group of organs that are working together for the same goal. The goal of the circulatory system is to transport materials to and from your cells and kind of all around your body. Another famous organ system is the excretory system, and it removes waste from your body. It includes bladder, lungs, and urine, which is a fancy science word for pee. So you might think that the excretory system involves pooping or poop, but that's actually part of your digestive system. The excretory system just deals with urine, pee, and actually carbon dioxide because you can't have a lot of carbon dioxide in your body. Okay, we're going to stop. Please hit pause because you need to take the levels of bodily organization quiz because we just finished our levels of bodily organization summary. So my suggestion, if you're working alone, I would maybe go back to the last few minutes of the video, watch the video as you take the quiz. Let's move on to homeostasis summary. This is our second chapter for the day. Cells, tissues, organs, and organ systems all work together to keep the body stable. Another word for stable is same all the time. So we call this homeostasis. So homeostasis is the body's tendency, or what the body usually does, to keep an internal balance. So a balance on the inside. And this internal balance is going to happen no matter what is happening outside of the body. So, no matter what's happening outside of the body tries really hard to keep conditions the same internally. And we call this process homeostasis. So, homeostasis will still happen even if the outside of the body is in snow, rain, or extreme heat. You don't want things inside your body to change too much. When that happens, you get sick. So again, your body is going to work really, really hard to keep the inside the same, regardless of if it's snowing, if it's raining, if it's windy, no matter what's happening. That's why our body temperature is pretty much constant, around 98 degrees. Okay, so shivering is an example of homeostasis. Remember, homeostasis is the body's tendency to keep internal conditions the same. So when you're in some place that's cold, like if it's snowing or winter, or you're in very, very cold air conditioning, your body might start to shiver. So you shiver when your body temperature is cold, and shivering actually produces heat. It will make your muscles tense up and relax, tense up and relax. And that action of tensing up and relaxing will actually create heat, and that heat will bring your body temperature back up. So it happens for a reason, it has a purpose, and that purpose is to maintain homeostasis. Let's think of the opposite of shivering. How about sweating? Sweating is another example of homeostasis. So it's a really hot day, like last week was so hot, you start to produce sweat when your internal or inside body temperature is too high. Again, it's for a purpose, it's for a reason. As the sweat dries, you cool down. So sweating's trying to protect you from your internal body temperature getting too high. So sweating and shivering help the body maintain a stable temperature. And when you're trying to be stable or you're trying to stay the same inside your body, that is homeostasis. Okay, so let's talk about another example of homeostasis. There's a skip of this poor boy who's getting scared. I don't know, maybe he's watching a scary video on YouTube. So we see that he jumped, okay? So what he did is he responded to something that was scary on his TV screen or computer screen. So responding to the environment like jumping when scared is another way for the body to maintain homeostasis. So it's not enough that you try to keep things like temperature the same inside your body. You also have to respond to what's happening outside your body. Are you in danger? Is there something that will harm your body? This also helps maintain homeostasis. So let's talk about an example. When you are scared or excited, like this guy in the GIF, your body produces a chemical called adrenaline. Maybe you've heard this before. When released by the body, adrenaline will give you a burst of energy that prepares the body for action. So maybe sometimes you guys feel like you're getting ready for a big game, and all of a sudden you feel this like rush of like maybe nerves and excitement, and you do like crazy well on the game, and you go faster and stronger than you ever thought you could. Possibly that's because your body sensed the excitement, released adrenaline, and that adrenaline gave your body a boost of energy so that you could last very long in the game. Okay, we're going to stop. We're done with homeostasis. So please take the homeostasis quiz. Again, I'm going to give you the same advice. Go back a few minutes in the video, watch the video again, or watch the video as you're taking the quiz. And when you're finished with that, bada boom, you are done for today, and I will see you back here tomorrow.